Welcome back, Math 2. Today we're working on page 311. We're going to begin solving these quadratics, or basically solving our equations for x. Okay. Now, there's quite a few different ways to solve quadratic equations for x, and each method is best used on different types of equations. So we are going to start with the most basic ones, where there's just an x squared term, or basically there's no plain x term. Okay, so we are going to start by solving them with square roots. Okay, so remember, a square root cancels out an exponent of 2. So what cancels out a square, or an exponent of 2, is a square root. Okay, or you could also call that a radical. So this is what we were doing right at the tail end of Unit 1. We were learning to solve all those radical equations, and we usually had to take the square root or square both sides to get rid of a square root. Now we're going the other way. We want to get rid of the exponent of 2, so we're going to have to take out this, we're going to have to use a square root to do so. Okay. Now when you take the square root of a number, okay, there's technically two correct answers. Okay. Let's say I wanted to take the square root of 16. Okay. Most of you would tell me right away that it is 4. Okay. But there's also another option that can create a 16 when it's squared, and that is negative 4. Okay, remember, you can have negative 4 times itself, making a positive 16. So there's going to be all of these are either going to have no answer, or they're going to have two answers. Okay. Another way we could write this, instead of writing them separately, we could write 1, 4 and have a plus or minus symbol in front of it. Okay. I'll take either way. I prefer writing it this way because I think it's quicker, but if you think you're going to forget what that means, then by all means, write them out separately. Let's try some examples. Okay, so our steps basically are going to isolate the x squared term. Okay, and they're not always x's, but that's okay. And then we want to take the square root of both sides. 1, 2. All right. So I'm going to start off with my first example over here of x squared equals 25. So in this one, my x squared term is already isolated, so I do not have to do step 1. I can move on to step 2 of taking the square root of both sides. That'll cancel out this exponent of 2 and leave me with x. And I know that 25, the square root of that, is 5. So that is either going to be 5 or negative 5. Again, you could also write that as plus or minus 5. Either one. And you know what? I'm going to do these in blue so you can tell where the original problem is. Okay. Let's move on to my second one. A squared plus 7 equals 88. So my squared term is not by itself yet. I'm going to have to get rid of this 7 or move it over to get it by itself. So I'm going to subtract 7 on both sides. And I end up with a squared equals 81, which is nice. I know that 81 is a square number as well. So I'm going to take the square root of both sides, and that's going to cancel out my exponent of 2 and leave me with a equals 9 or negative 9. Oops, not 19. Sorry. Or you could also write that as a equals plus or minus 9. Excuse me. Okay, let's move on to example 3. So far we've had all these nice square numbers. Let's see what happens when we don't, though. So I have 2h squared minus 5 equals 73. So again, I have to get some things away from h squared. I'm trying to isolate this piece. So I'm going to start by adding 5 to both sides, and I'll still have 2h squared over here, and then I'll have 78. I'm going to divide by 2 on both sides, and I end up with h squared equals, what is that, 39? Let's double check. 39, yep. Okay. Now I know off the top of my head that 39 does not have a square root. Okay? And in the past, when we were dealing with square roots, I told you that we had to absolutely simplify it down. 39 actually doesn't simplify down either. It would stay the square root of 39. But because of what these answers are used for, we are going to go with some decimal answers sometimes. Okay, I'll let you know specifically when you need to simplify, but for now, decimals are going to be okay. All right, so I'm going to take the square root. Now I can still have a positive or negative version of this answer. Okay, and because I'm running out of room, I'm just going to write the plus minus version. So I'm going to take the square root 39. Not very pretty, but we're going to round that maybe to 2 decimal places. So 6.24, positive or negative. Okay. And the reason that it's okay to use decimals in this scenario is this is often used for graphing purposes. And it's a lot easier to understand where 6.24 is on a graph than to figure out where the square root of 39 is. Okay. All right, one more problem here. Okay, I have negative 7n squared equals 448. I'm going to divide by negative 7, and I get that n squared equals negative 64. Okay. Now we also know 64 has a nice square root, but negative 64 does not. If I try to type it in here, I get an error. Okay. Remember, those negative numbers, we have to either use imaginary numbers to get an answer out, or in this case what it means is no solution. Okay, because there are no square roots of negative numbers. All right, so what do these answers mean? What do they tell us? Okay, that's great. I found out what x is, but what does that actually mean? Okay, so these answers, what x equals, these are the x-intercepts of the graph. Okay, and remember that graph makes that U shape. It's called a parabola. Okay. So sometimes you can end up with, well, a lot of times, most of our answers had 2 solutions, and here's why. Okay, so here's what 2 solutions looks like. 2 solutions looks like, oh, my graph is going to cross the x-axis twice. There are 2 x-intercepts. Occasionally, you will end up with 1 solution. We didn't today, but this would happen when you have x squared equals 0. Okay, we didn't do an example like that, but that's how it would look. Okay. And this looks like this, where the graph is just hitting my x-axis 1 time, and that 1 time would be the vertex. So this one would have to be the x-intercept is also the vertex. So, a no solution looks like this, when my graph does not even touch the x-axis. It doesn't come low enough or it does not come high enough, because remember, all these graphs could be flipped down as well to look like this. Do little mini ones. They could all be flipped down. Okay. So no solution is when it's not going to cross the x-axis at all. And you saw examples of those types of quadratics in our Unit 2. Okay. So here is your first method for solving quadratics. This is the most basic one that we want to use when there's only an x squared term. There's no other x's besides x squared.